short, I would like to give you a first-hand direct point of view of the smart grid from the instrument transformer manufacturers themselves, PROSPECTIVE. First of all, I would like to speak about smart grid from our point of view because it has presented both advantages and challenges that we have been forced to recognize and reconcile. I would like also to speak a little bit about IEC 61850 fiber optic instrument transformers and some strategic plans of PROSPECTIVE to align synergies with the foreign companies. Challenge number 1. There are too many secondary devices that we need to connect to the instrument transformer. First, there are protective relays that are followed by revenue metering, bay controllers, and power quality monitoring. We are aware that smart grid deployments will probably need some additional equipment connected, but we currently have a limited number of secondary windings of the instrument transformer as well as limited power on the winding. And this is the challenge for the conventional electromagnetic instrument transformer. The second challenge incurred is that of our high voltage direct current lines. Realizing that some HVDC projects are being deployed in your country and throughout the world, as we have some here in Russia as well. We have encountered an issue with the metering. The only effective way of metering is to meter on the AC side before the AC-DC converter. But the question arises, what if we have different lines with different owners or between different countries? How could the quantity and quality of the electricity be controlled and regulated? One option might be to set up the metering directly on the borders, and this would be a challenge. All of you probably know about the IEC 61850 standard as being the main standard for digital communication in power energy. And that migration to digital communication in power energy is inevitable. So, it is very hard for me to imagine that we will not transfer our secondary systems to digital communication in the near future. Another point is there is no real alternative to IEC 61850, and that is why the protocols described by this standard include real-time application communication. For example, the protocol that allows us to transfer sample values to current and voltage measurements has never been available or used with no other communication standard. However, the drawbacks of IEC 61850 standard are associated with the fact that this standard is new and very complicated. In fact, at the moment, it has about 26 documents included in the standard, and they are pretty big. Another problem is those people who don't want to study this documentation. Just say that this standard is not mature enough. The protocol and standard IEC 61850-9-2 is ideally fit to introduce fiber optic instrument transformers and non-conventional instrument transformers for power energy as a whole, because it ensures interoperability of the instrument transformer with digital interface with other secondary devices like protection, metering, power quality, and so on. I would like to introduce you the fiber optic instrument transformers developed and produced by PROSPECTIVE company. So, our product line of the PROSPECTIVE is presented on the slide. The fiber optic current sensor, the fiber optic voltage sensor, electronic interfacing modules, and the open loop AC-DC current sensor, which I will describe a little bit later. Starting with the fiber optic current sensor, it looks like the conventional instrument transformer, with the only difference being that it is much lighter in weight. This instrument, for only 110 kilovolts, is only 70 kilo compared to 500 kilo for the conventional instrument transformer. The difference is due to the optical sensor, which is located at the top of the support insulator. We are only using a special optical fiber inside of this sensor. This special fiber is used to sense the current flowing through the current carrying bus. Because of this, we have several options. We can have one optical cable with two optical fibers for metering and for protections, or we can have an additional second cable for redundant protection schemes. These items are installed in the switch yard along with the electronic modules with IEC 61850-9-2 interface. They are installed in the control room of the substation. I would like to say about characteristics of this sensor. It can be used in any voltage you like because it's absolutely insulated from the primary voltage. So it is independent of the voltage in the line. The second, we have very large and very broad rated primary current, and it can be from 300 to 40,000 amps rated current. The interface is fully digital according to IEC 61850-9-2 protocol. Its accuracy class 0.2x for metering and 5p for protection. And the weight is 70 kilo for 110 kilovolts and 110 kilo for 220 kilovolts. Its weight depends only on the weight of support insulator, not the sensor itself. A few words about the open loop. The open loop is just the same as the previous sensor, but we don't have this insulator. We just have an optical fiber cable that can be used for both for AC and DC currents. It has different interfaces, including digital, analog and wide range of currents. The voltage sensor is not actually the fiber optic sensor itself. This is based on the capacitor divider, and we have an analog to digital converter in the base. But the unique thing about this sensor is we don't have any power supply going from the control room to the AD converter except the optical fiber. This makes it good because we don't have any problems with EMC compatibility. So it is easy to pass any tests and we don't have any problems with high frequencies. Characteristics of the fiber optic voltage sensor are the same, but it is a little bit heavier. The application areas where we need high power consumption are the power energy, power stations, substations, HVDC lines, large power consumption industries, and electrified transport. We are not proposing to start a revolution in the industry, but we are proposing the opportunity to convert to digital substations with a practical step-by-step process. The first step is a revenue metering system. The new equipment being installed would be parallel to the existing conventional instrument transformers. For this, we don't need much space for installations, as they can be installed near the existing transformers. This would permit for the interface of the fully digital IEC 61850-9-2 fiber optic electronic modules. This revenue meter is produced by our partner company, PROSPECTIVE Systems. The revenue metering data and the measurements would be in accordance with 104 standard, the power quality EN 50160 and other international standards. Step number 2. This is a fully digital substation where the sensors are already installed. you do not need to change them. Simply use them and add other electronic modules. By doing this, we form the full IEC 61850-9-2 process bus where you can connect any secondary equipment. This is the revenue metering which we have in the first step. This will provide for the protection and control for power quality monitoring of any secondary equipment. And by the way, there are many secondary equipment options available with the 9-2 interface, so this is not a real issue. Point 5 is the reference application of instrument transformers by Profitec. The first application is an aluminium melting facility in Rusal, Krasnoyarsk, Russia. In 2011, Profitec installed a set of instrument transformers for DC current measurements. This is a very special installation case because this DC current measurement has up to 200,000 amps of DC current. At this installation site we had 5 sensors installed and they are being used for current control at the electrolysis tank series facility. Since 2012, they have proven to be efficient and resistant to great electromagnetic fields due to high currents there. Project number 2 is a very interesting project, which is located in the far east of Russia. This complete cluster is referred to as the test bed for smart grid. This is a cluster of 4 substations which is going to use the IEC 61850 standard to process all communications in the substations, including the IEC 61850-9-2 process, goose messages, MMS, etc. Of the 4 substations, Profitec will install the instrument transformers on one of them, and there will be 2 3-phase sets of combined current voltage sensor for 220 kilovolts. Project number 3 is the steam power plant installation in Moscow, where we use the open-loop current sensor. It was actually wound around the current carrying bus without the need to dismount the bus. This is really good for real case installations, as you are not required to dismantle anything. Just install it without the need to stop any equipment for a long period of time. Simply wind the fiber optic cable around the current carrying bus. This is used for both revenue metering and for accuracy testing of the installed instrument transformers, like second reference instrument transformers. Number 4 is the installation setup at the R&D Center substation in Moscow, where there is a switchyard 110 kV installed. Here you can see the fiber optic current sensor and the voltage sensor. The main idea of this project is to check the declared characteristics of instrument transformers, including the accuracy and the performance of digital interface. There are currently several other projects in Russia using fully digital substations, and these projects are being deployed and monitored by the Federal Grid Company. The first project that Profitec has been involved in is the digital revenue metering in the Tatarstan Republic of Russia. This system will be integrated in the billing system of the Tatarstan Grid Company upon its completion. Profitec is actually not a global company, and in fact it develops and produces unique devices that need support from both the side of engineering companies and other companies. Our prospective aims are production of complete solutions for digital substation based on fiber optic instrument sensor, expansion to foreign markets, and therefore we need strategic partners experienced in deployment in innovative projects and products in power energy, and clients in the sphere of power energy and large energy consumption facilities interested in the deployment of innovative solutions. Our cooperation opportunities is pilot installations, series installations, and transfer of technology. Thank you.